So we're now going to walk through the source code for the Java ShutdownOnFailure nested subclass. And again, remember, this is nested inside of the structured task scope class, and it inherits from structured task scope. So you can find this code as before at this link at the bottom of the slide, along with all the other code that's part of Java 19. So here we are back in the IntelliJ project for the structured task scope.java file, and we're looking at the ShutdownOnFailure nested subclass. You can see it's a nested class, and it extends structured task scope, and it's just parameterized with object. We don't really care about the details because we're not trying to get a single result here. So as we saw with ShutdownOnSuccess, it has a var handle that it's going to use to be able to atomically access the contents, to set or get the contents of the future field, which is defined as volatile, so it can do atomic reads or writes using the mechanisms provided by var handle, the compare and set operations, for example. And there's also this static initializer block, which goes ahead and uses a var handle to get the futures, sorry, it's not the futures field, it's the future field. It goes and gets the future field from the ShutdownOnFailure class. For this particular field, it finds the offset in the object in the class, and then treats it as a future, and that way we can go ahead and do these atomic operations on the future field. Again, this is just a very common Java concurrency idiom especially for the internals of the Java execution environment. Let's take a look at the constructors. They're pretty much the same as ShutdownOnSuccess. It's just ShutdownOnFailure. We can have a named constructor with a thread factory, so we can either have platform or virtual threads. Or if we take the default constructor, it just goes ahead and has an unnamed scope that will make virtual threads. Without loss of generality, let's assume we're working with virtual threads. So once again, the operative method here that really matters is handle complete. All the other methods, or most of the other methods, are inherited from the structured task scope parent abstract class, or not abstract class. It's really it's a class that's the parent class, superclass. And you can see what handle complete does in this case is a little different from ShutdownOnSuccess. Keep in mind that the semantics of ShutdownOnFailure are to keep going until all the tasks finish running successfully, or shut down on the first failure and keep track of what went wrong. So here's what it looks like. So handle complete is past a future, which is a task that just completed. We saw how that works when we looked at the structured task scope method that implements the future impl with the future task with the done method, which calls back on handle complete. And what it does is it grabs the current state of the future that's just completed. If for some strange reason it's still running, chaos and insanity have ensued, so we throw an exception. That shouldn't happen under normal circumstances or even abnormal circumstances, but we do a sanity check there. Otherwise, if the state indicates success, that means the task has completed successfully, we just return because we want to keep going. We want to keep going. As long as everything succeeds, we're going to return, because when everything's done, then we're going to go ahead and join. So on success, we just go ahead and return. Otherwise, something's gone wrong, and it's either a failure or a cancellation. And that's intended to cause the scope to shut down. So what we do here is we try to set the future that just was shut down or just failed or was canceled. We take that future and we slam it into the future field in the class, because we want to keep track of that for later parts of the code that are going to work on it after we return from join. And after we do that, after we successfully transfer the future that failed or was canceled into the future field in the ShutdownOnFailure object, we then shut down, saying, shut everybody down, something's failed, something's been canceled, it's time to close up shop. So that's what handle complete does for ShutdownOnFailure. You can see that join uses the parent's join call, join until uses the parent's join until call, but there's a couple of other methods here that are not inherited from the parent. They're new methods. One gets the exception that's occurred, which is either going to be something that is an exception or an optional if there was no exception. And then you can also see there's this method we've looked at before called throw if failed. And the idea is after you call join and join returns, then you can call throw if failed to see if anything went wrong. And in fact, if you take a careful look at join, you'll see that the join method returns shutdown on failure, returns this. And that allows you to be able to chain together the call to join with the call to throw if failed, if you choose to do it that way. What throw if failed does is it takes a look at the future that we've stored in the field. And if the future is null, that means everything finished successfully. We're all done. So we throw if failed becomes a no-op in that case. However, if it's not null, that means something was either canceled or it failed. So we take a look at the state of the future that we stored. If it was failed, we throw the execution exception with the actual exception that failed. Otherwise, if it was canceled, we throw the cancellation exception. So that's what throw if failed does. So if all goes well, this basically turns into a no-op. But if something's failed, we keep track of what failed and we're able to throw the proper exception. And there's also a throw if failed that's given an exception to throw in that case. So that's basically the implementation of success or shutdown on failure. You can see it's very, very similar to shutdown and success. It's just the success criteria as embodied by the handle complete hook method is slightly different.